I'm Marv Wessel, CEO of Global RF Solutions. My company specializes in the analysis, measurement, and mitigation of human exposure to radio frequency radiation. I've received many phone calls from workers in the wireless industry similar to this. If my fill-in-the-blank personal monitor keeps alarming at this site, am I safe from RF exposure? Well, with so many RF monitors available on the market ranging from gadgets to professional equipment, that's often a difficult question to answer. Since there have been no real independent tests of RF monitors to date that could help answer that question, I felt that an independent evaluation by a company that doesn't sell RF monitors was needed. Exactly what is an RF monitor? Well, IEEE standard C95.3 states, personal monitors are typically small portable broadband detectors suitable for attachment to workers' clothing, which are equipped with an alarm feature for alerting the wearer to the presence of high-level RF fields that may approach the MPE of interest. A personal monitor should assist workers from exceeding the maximum permissible exposure limits, or MPE, but it should not unnecessarily impede work when an exposure risk doesn't exist. False alarms are as detrimental as no alarms in some situations. If you or your employees cannot work in an environment because your monitor alarmed falsely, that would be considered a negative feature. Conversely, we want our workers to be warned when a potential RF hazard is present. You may be asking yourself, when is an RF monitor required? First, you need to determine how and where you intend to use the monitor. If you're working at a satellite teleport or radar facility, you will be primarily concerned with microwave frequencies above 2 GHz. If you're required to work around industrial heat sealers, an RF monitor that works in the low band frequencies around 27 MHz will be required. Commercial broadcast sites typically cover a broad spectrum of VHF to UHF and possibly microwave frequencies. VHF frequencies are most readily absorbed by the human body, and the maximum permissible exposure limits are lowest between 30 and 300 MHz. The reason for this is to help prevent the dangers of deep heating effects on workers that, if unchecked, could result in injuries similar to heat stroke. Cellular and PCS sites include 700 MHz through 2000 MHz frequencies, but these sites are often co-located with sites containing VHF emitters to include commercial broadcast and FM radio frequencies. Obviously, a personal monitor that covers the broadest range of frequencies is the most desirable for professional personal protective equipment use. The objective of our independent tests will be to separate the professional PPE RF monitors from the gimmicks and gadgets that are sold as professional monitors. We will test units in the hand, but the IEEE standard defines a personal monitor as portable broadband detectors suitable for attachment to workers' clothing. A pass or fail grade for any monitor we test will ultimately be determined on how well it performs on the user's body, hands-free. It's relatively easy to build an RF monitor that measures RF fields on a test stand in a test chamber. Building an RF monitor that accurately measures RF fields on a user is a more challenging task. I've collected a variety of different monitors for our test. They're all designed to detect or monitor RF radiation to hopefully protect the user from overexposure. They appear similar, small in size, some with audible and visual alarms, battery-powered with limited controls and displays. They're all designed for a single purpose, to be an RF or microwave monitor. Their designs on the inside are as different as their prices, from a low of about $30 on this end to a high of around $2,000 on this end.
Welcome to Global RF Solutions RF Test Facility. This is a real-world test facility using actual antennas and emitters that you would find in the real world. No anechoic chambers. This is all real-world RF exposure with RF exposure to the bodies. We're going to be calibrating all of the measurements that we make for the interaction with our personal monitors by determining where the FCC occupational limit is exceeded using calibrated test equipment, and then we're going to test these units both on our body, off the body, in a hand, and we're going to test them for accuracy against calibrated test equipment. We're going to use 27 megahertz, which is HF, or long-range communications, which isn't used very much anymore, but industrial heat sealers use 27 megahertz. We've got a 145 megahertz emitter, which is almost the center of VHF, which our human bodies interact with the most. We also have a 900 megahertz emitter, and that's going to simulate the downlink of cellular transmitters, actually using a cellular antenna. And we've got 1900 megahertz, which is PCS frequencies or lower microwave frequencies. This is the cell sensor. This little device was obtained from a big box retail chain for about $30. The user's manual contains pretty detailed instructions, and the display has 2 ranges of detection. They claim it is calibrated for a plus or minus 3 dB accuracy, but there is no calibration data to support this. There is no user case or belt clip, and it's powered by a 9-volt battery. This unit performed poorly over our broad range of test frequencies, but did pass a few tests in the 900 to 1900 MHz range. It's very sensitive to field polarity and is not designed for on-the-body use. As far as ergonomics are concerned, it's easy to use and the display is easy to read. But I would classify it as a gadget, and it is appropriately priced for its demonstrated performance. This is the Micro Alert 2. This is the smallest monitor that we tested. I ordered it online for about $100. According to the manual, the device has a very broad frequency range from 6 MHz to 3 GHz. The advertised sensitivity is for up to 10 microwatts per square centimeter. A calibration certificate was not included, and it uses a CR2032 battery, and a screwdriver to replace the battery is also included. This monitor reacted to every frequency we tested. Unfortunately, it proved to be too sensitive for use as a piece of personal protective equipment. It failed every one of our accuracy tests, and in my opinion, this is just an overpriced gadget. This is the Field Sense. The typical cost for this unit is around $500. The user's manual is pretty straightforward and easy to use. The monitor has 2 different modes, a measure mode and a monitor mode. It uses non-standard N-type batteries, and the unit is only designed for a frequency range of 380 MHz to 2700 MHz. Unfortunately, that does not cover commercial broadcast and FM transmitters. And according to the manual, it is not designed to be worn on the body. A calibration certificate is included with a 2-year calibration interval recommended. Unfortunately, the certificate does not list traceability to any standard. This unit didn't respond well outside its advertised frequency range, but passed some of our tests in the 900 to 1900 MHz range. Unfortunately, it is so sensitive to polarity changes that a 90-degree change in monitor polarity yields results from 0% displayed to full-scale readings of 250%. Actually, our first $30 monitor that we tested performed better in this frequency range. Considering the price, this unit is a disappointing gadget. This is the Safe one. Although this unit appears to no longer be available from the company that sold them, there seem to be plenty of them still in use since we get inquiries about them, so we'll include them in our test. They used to cost around $700, and the manual is pretty straightforward and easy to use. The manual claims it is designed to be worn on the body using the belt clip or protective case. It has visual and audible alarms and is powered with 2 AAA batteries. Oddly though, it does not have an on-off switch, and that seems like a potential problem, but a 500-hour battery life is advertised. A sensitivity chart over frequency is included, but nothing stating the unit is calibrated to any traceable standard. Its advertised frequency range is 10 MHz to 10 GHz, but absolute accuracy is 400 MHz to 2500 MHz plus or minus 6 dB. This unit did not perform well over its advertised frequency range. It greatly underestimated 145 MHz VHF fields greater than the occupational limit, yet was extremely sensitive at 1900 MHz or PCS frequencies and is likely to produce false alarms there. This unit was very overpriced for the quality and definitely should be considered a gadget as far as personal monitor use is concerned. This is the NARDalert XT. Even though this monitor is no longer being produced, it is supported for both service and calibration. With many thousands of these units in the field, I thought it would be relevant to test these too. The unit comes with 2 different clips, and it's designed to be worn on the body. This unit is designed to be used at frequencies between 100 kHz and 100 GHz. It uses a standard AA battery, and it came with a printed user's manual as well as a video user's manual on CD. When worn on a belt or in a pocket, the alarm LEDs are very easy to see. It has a 2-year calibration cycle, but the calibration certificate does not include a traceable standard. This unit passed every accuracy test over our test frequency range, except for handheld use at low frequency. The unit was not designed for handheld use, and it was still very close to the plus or minus 6 dB limit. Since it works on the body at that frequency, we gave this unit a passing grade. The ergonomics of the unit are also very good. This monitor definitely qualifies as a personal monitor and not a gadget. This is the Radman XT. The user's manual is straightforward and easy to use. This monitor is the only one that claims to detect the E electric field and the H magnetic field. The E field is detected between 3 MHz and 40 GHz. The H field is detected between 3 MHz and 1 GHz. A certificate of calibration is supplied to traceable standards. As a personal monitor to be worn in a pocket, the yellow cap stays on to reduce interaction with the body. The second mode is using this monitor as a peak detector. You must remove the yellow cap with absorber material and typically place it on the bottom. You now have a fairly isotropic detector to use in a quasi-survey type function. The unit is powered by 2 standard AAA batteries, and it also has a fiber optic output for remote data collection. The unit passed all of our accuracy tests, including calibration to a traceable standard. The unit does have some ergonomic shortcomings. The clip design encourages the user to wear the unit incorrectly. The display LEDs are also very difficult to see when wearing the unit. Considering the accuracy of the unit over a large frequency range, I would definitely classify it as a professional personal monitor, not a gadget. This is the NardAlert S3. This is NARDA's replacement for the NardAlert XT. It comes in a very nice case with a printed user's manual and soft copy PDFs as well as software on a CD. Even though this monitor is packed with features, it's ready to use right out of the box. It's also the only monitor with a rechargeable battery, so replacing batteries should be unnecessary. This is the only monitor tested with a replaceable sensor. This means that the user can replace the sensor in the field to keep the calibration current. The included calibration certificate is traceable to a standard. A protective rubber sleeve is included to increase the durability of the unit. A belt clip is interchangeable with a lanyard attachment, and it has a very bright and easy to read screen, as well as flashing LEDs and an audible alarm. The unit is designed to be used on the body for hands-free use. The sensor installed in this mainframe is a 2271 that is used for frequencies between 100 kHz and 50 GHz and shaped to the FCC control limit. The separation between the low frequency and high frequency sensors occurs somewhere around 1000 MHz. This can be an extremely useful feature to help identify the actual RF emitter sources causing alarms at a site. This unit easily passed all of our accuracy tests. I found that it has numerous features and yet is extremely easy to use, including menu navigation. It also had the greatest dynamic range of all the monitors tested, with 400% of the occupational limit being detected and displayed. With the high visibility screen, LEDs, audible alarm, and rechargeable battery, it scores very high in ergonomics too. This was the most expensive monitor, but in this case, you get what you pay for.
In summary, I've tested several devices in a simulated user's environment. Although inexpensive units are capable of detecting RF fields, the variations of frequencies and field polarity combined with the interaction of the user's body proved to be too challenging for many of the units that I tested. Remember that in real-world conditions, the users in most cases will be completely unaware of the frequency or polarity of the RF field they're being exposed to.